So last lecture I talked about the fact that in auth it breaks down into two separate words that start with auth. Right? We talk about authentication and authorization. Does anyone know what the difference is between the two?
Authentication with the database.
Say that one more time.
Authentication with the database.
Authentication is with the database. It has to do with the database, certainly.
Yeah, authorization.
I mean, just the words like authenticate is like proving that like you're okay, and then authorization is the permission that's going to keep it.
Yeah, we have not permission.
That is exactly correct, right? Because in English, words mean things, as they do in like every language. All right, words mean things. It's one of my favorite things to say, actually. Words mean things. So when you authenticate, it simply means you are who you say you are. And authorization, it means, are you allowed to do something? They are completely separate. Here's a good example. Who here has flown or been to an airport? Great, to all of you, right? When you go and you check into the airport, what's the first thing they ask you for?
Passport.
Yeah, your license or your passport, right? They want to know that, hey, if I walked up there and I said, hey, I got a ticket to the Bahamas. Great, who are you? And I'm like, I don't know, Donald Trump. And they'd be like, all right, cool, Mr. President, no big deal. I got you on Air Force One. Here we go. Absolutely not. I think I'm gonna want to see that ID. That ID was been verified by the state or by the federal government. And so if I can see your passport, there's a picture of you, and I look at your face, I've authenticated that you are who you say you are, and I will now print your boarding pass. That boarding pass authorizes you to fly. Now, once you have been authenticated, are you authorized to get on any airplane in that terminal?
No.
Absolutely not. You're allowed to get on one gate, one bird, one flight. And so the difference here is simply you are who you say you are versus you are allowed to do what you have the privilege to do. So for example, certain applications, right? As a bank app, which I like to use very often, are you allowed to adjust your bank details, like your account number or the amount that's in your bank account? Wouldn't that be nice? 9999999. All right? So you're authorized to simply view. That is a read only. You'll authenticate by putting in your username and password. Right? So there are differences. Now, if, however, there is a random debit from your account and you're like, hey, I did not do that. That's ridiculous. That wasn't me. I don't know who this Nigerian prince is. I don't know why they're taking my money. So somebody that has admin privileges is authorized, that works for your bank, to be like, you know what? That makes sense. Everything checks out. I will now credit your account the $1,000 that you emailed somebody in this get-rich-quick scheme. Cool? And so there's certain people have different access to the website. Sorry, is this distracting? It's the same loop over and over. I see all of you like staring at it. Cool. Is there any questions on authorization and authentication and the differences?
How does it work?
That is I'm going to get to that, but just the differences. Thank you for that, not a plant, because I will now tell you how it works. So the idea here is that part one is simply we're going to be talking about authentication. Part two, this afternoon, we're going to be talking about authorization. So that's going to be more like the login. And then once you're logged in, who is logged in and what can that person do? So the authentication portion, this part of the lecture, is going to be simply how do you actually authenticate somebody? So the first question I want to ask is it a good idea to store plain text passwords into the database?
No.
Oh, wow. There's usually like a deadpan silence, and I'm like, okay, all right, but good deal. Great. So the idea here is that we don't want to do that, right? Let's just say I have a user, and they sign in, and they get created. What RESTful route does that allows me to create a brand new user? Post is the RESTful route?
Create.
Great, it's the create action. Cool. And it's usually a post to / users. You gotta finish the whole sentence. I'm trying to train you to speak technically. Cool. So it's a post / users hitting the create action. So let's think about that create action. Cool. Boop, boop, boop. Hit this. In my user's controller, I see this create. Cool. I'm gonna drop this by bug because it's very important. And then I'm gonna have this. It's gonna permit username and password. Pretty simple so far? Cool. Let's take a look at the schema though, and how I've set this up. What do I have here?
Password digest.
Right, I have password. Thank you for saying that so enthusiastically. Password digest. The interesting here is what does active record, application record, do for me in regards to the attributes of my database? What does it build for me immediately? Tricky stuff.
Encrypted row.
The encrypted row. Not necessarily, but I like the guess. Huh?
Attribute methods.
That's right. The adder reader and adder writer. Do you remember that? It's coming back. A little R tab. That would have been useful in Mod 1, right? W tab. Ooh. Powerful shortcuts. Cool. And what does it create the adder reader and writer for? Yes.
Initialization.
Okay, so the adder reader and the adder writer simply allow you to read the attributes, and the adder writer allows you to write the attributes. So if I had an attribute like name, as you all love to create in your attributes, it does this, def name, and it simply does name. So far so good? And then what does the adder writer look like? Def name equals some sort of new name input, right? And then it's going to go name equals to whatever I put in here, the new name. Are there any questions on just the adder reader and writer? All right, good deal. Cool. So quick mod 1 review. That being said, if we take a look back at the schema, what do I have here in my database?
Password digest. Woo! Yeah.
Powerful. Yes, I have password digest. Do I have an adder reader and adder writer for password?
Not yet. Yes.
For password.
No.
No.
Password or password digest? Which one do I have now?
Digest.
I have password digest, right? Cool. Let's just take that into consideration carefully. So that's an important review. So let's think this through, right? What I want to do is I want to create a brand new user. So what is the RESTful route for that? Slash new? Okay. User slash new. Yeah? Cool. I get this weird error. Undefined method password. Did you mean password digest? What file would this be possibly in? Where would that possibly be? Okay, very good. I'm trying to hammer this home because you need to understand, right? It should be very fast and very easy to debug Rails. All right, great. I have a form for. Why is form for trying to do something with the password? How does form for work? What is it trying to do with this right here?
Slash user to the variable username.
It's attempting to invoke the method username on user, and then invoke a method password on user. Does that sound familiar? Yes, no?
Yes.
Okay. I love the confidence. All right. So it's trying to invoke that. Therefore, do I have a method called password on user?
No.
No, we've determined that. What do we actually have though?
Password digest.
Great. Who feels comfortable with this error message? Just 4 of you? That's
What do you
okay.
mean comfortable?
I'm talking about you understand why this error message is here.
Words.
Cool. All right, great. Now that if you understand it, how do you fix it?
Change password. This is a trick question.
No, that's not a trick question.
Oh, do the password digest.
Interesting. I could do what password digest? You want me to change this to password digest?
Probably the label too.
Yeah, that's fine. No, will this work?
Yes.
Cool. What if I told you you cannot do that? Is there another way to fix this?
Add password to the schema.
That would also fix it. Add password to the schema. Is there another way?
In the controller, custom,
Redirect your password digest to the form.
Okay, ready? Let's read this undefined method password. How do you define the method password? Smart. Cool. And this can just return anything right now. It's sort of a placeholder. So let's just put add password as like what it's supposed to look like. And if I refresh, should the error go away?
Yes, we'll see.
I mean, we will see, but who feels confident in what is happening?
we might get another error with this one.
Very fair. Who thinks it will not be at least, at a minimum, not this error? Very good. Cool. So what I'm going to do is inside the controller, in the create action, I'll hit this bug. So I'm just going to put in, does anyone want to be a user?
Jack. I'll take any.
Wow, Jack. And what's your absolutely not real password?
PA Rivers. That is true. It is not Rivers.
PA Rivers?
PA Rivers.
PA Rivers. Okay.
Jokes in this class.
Very good. Yes, I understand that. Great. So real quick, you see how this user experience is terrible? Do you want to be able to like display this?
Yes.
Yes?
If you click a little check.
Yeah, that's true.
Oh my lord. Stop the madness. Great. All right, I'll show you guys real quick. So instead of text field, you simply put,
Password.
wow.
So simple.
All right. Cool. All right. I know. For demonstration purposes, I'm just going to leave it as text so we can see it. So, all right, cool. Ready? Jack. All right, let me just refresh this. Old Jack, PA Rivers. Cool. So if I create user, what happens? Oh, smart. Bug. Let's think this through. What are my user params?
Username and password.
Let's check the params. Cool. I have what coming through? Username and password, right? So I want to make sure that in my strong params, what should be there? Password, not password digest. This is going to start to make sense right now. Are you ready? So we've determined that we do not want to save this plain text password in the database. What I have to do is intercept the password, and I have to change it into a non-human readable hashified string. That's the problem. That's the issue we're trying to resolve, right? So what I can do is, if you remember what the attr readers are and the attr writers, I can then take, when it attempts to save, I can say def password equals. And we'll take in a plain text password. Cool. And right now, what I want to do is something to the plain text password. Then save it to my database. Is that fair?
Yes.
Cool. So I want to introduce something to you called bcrypt. So there's a gem called bcrypt. What is this double semicolon? It has to do with inheritance, but what is it called? That's right, name spacing. Very good. It's okay, don't worry. There's like a million terms thrown at you. And then you think you understand it, and then you don't use it for like 4 days, and then it's like gone. All right? There's a lot coming at you in this boot camp, and so you should be proud about how far you've really come. Because if you really think about the amount of information you're absorbing, it's probably close to like 50% of everything that we're teaching you. So I would recommend watching those videos again, even if you feel like you understand it. I promise you, at this point, you will glean some nuggets of wisdom, like, oh, that's right, I remember that. And their interviews, they understand you're new, but that doesn't mean that they will let a lot of things slide. You will have to understand the technical terms. So this namespace has to do with inheritance, and I believe I'm incorrect. It should be this. Let's see. Great, that exists. Otherwise, what would I see there?
False. Error.
Error, right? Like, is there like a class in here like ya boy? Like, no, that doesn't exist. It's uninitialized constant. The fact that this didn't run an error means that is in fact inside my application. It is available. So bcrypt is a gem. Before I get into it, the first thing we should do if we're messing with a brand new gem is look at the docs. Let's just look at the docs. Yes, we should bundle. We should look at the docs to understand what it does. So let's take a look at that. What's this? Oh, boom. Pulled it up like a champ. If you don't know, you can simply do, let me Google that for you. Bcrypt, Ruby. Wow. Wowzers. There I am. Cool? So, what you get is fairly good documentation about what's going on, right? What versions you have to do, how to install it, how to use it, what it does for you, all right? It's all here. That being said, I'm not going to teach you how to read, but I will teach you how to go through documentation because it's so important as a developer as you try to build new features. So let's take a look in this library folder, inside the bcrypt folder, inside the password folder. Here you have a module bcrypt. And what it's going to do is inside the module, there's a class password. So that's where this is coming from. There's a module bcrypt, namespace. Inside the module, there's a class password. So far, so good? Check. Cool. And here you have a lot of readers. Right? We won't get too much into this, but I promise you the documentation is worth looking at. What we want to do is we want to be able to use it. So before I reveal all the magic that's in there, let's see it work. I want to be able to create, and let's just say I had a password like PA Rivers. Powerful password. Cool. Let's see what it returned to us. Look. Wow. Would that be safe to save inside my database?
Yes.
Absolutely, right? I should not be saving PA Rivers in the database. I haven't personally experienced it, but I've heard rumors that there are like bad, malicious people on the internet that want to steal databases and passwords. If they got a bunch of usernames and this, it's not very useful to them. All right? So, yeah?
So question about how the gem or in general other systems generate that code. Don't they follow like a specific algorithm or no like a specific, I guess, machine code to use? So if you found what they use, couldn't you easily crack all the codes?
So the question is, there is an algorithm that they run that what it does is it hashifies this, right? It turns this into some random string. So I can create my own hashing algorithm. It's very easy. I can simply take in any string like your boy, the fancy version. And I can do reverse. Wow, what a great hashing algorithm. The problem is, as you've mentioned, is extremely easy to crack. So this bcrypt is generally good industry practice, and it was developed over the course of a few years by, I want to say, 2 doctorates from MIT. It has never been broken. It is a one-way hashing algorithm. The reason it needs to be one-way is because if it was ever two-way, I can, in theory, in a two-way reversible algorithm, take this and somehow recreate the string PA Rivers. It is not currently possible and has not been cracked.
Isn't
Right.
that algorithm in the gem now? That's what I was thinking.
You would think the algorithm is in the gem, and I will show you where it's not. Cool? Yeah. That didn't make sense, but hopefully it will in a second. So what we want to be able to do is take this string and literally compare it to PA Rivers and have that return a Boolean. That's what I want to do. So I really want, in an ideal world, somehow to take this string, cool, and just be like, hey, does that double equal PA Rivers? And what am I going to get? Absolutely false. That's ridiculous. That's never going to work, right? Cool. Here's the thing, though. Let's take a look at this. Let's think about this right here, this create action. What is this actually? If I were to check the class. Think again.
An object.
Yes, what type of object?
A bcrypt password object.
Yes. Because if I were to do user.new and I would, or user.create, and I would check the class, what do I get? A string? Do I get a number? I get a instance of user. So if I were to run bcrypt password.create, I get an instance of the bcrypt object. It looks like it returns a string because that's what it's supposed to do. So let's check it. If I were to do this and pay close attention to this string and what comes out. Oops, that was embarrassing. Boop, boop, boop. Let's do this. Cool password equals to this thing. PA Rivers. Boop, boop. Cool. You see this? Oh, you see this? Try again. Oops. Let me do this real quick. Ready? Bloop, bloop, bloop.
The first few digits are the same. The first 7.
Yeah, these look the same. Sure. What about the rest of it?
Sure.
Are they the same?
No.
No. Why would that be useful to you? Yes, because if somebody used the same password, right? If you literally Google the top 10 like most commonly used passwords, they use like 1, 2, 3, 4. Super secure. I think I looked it up like a couple years ago when I was doing this lecture. Michael came up, and I was like, cool. Don't know why, but Michael is up there. The idea is that if I use the password Michael, and you use the password Michael, and if I'm this hypothetical bad guy, they're real bad people. I'm being facetious, right? They're like hackers out there. If they stole a few databases and simply matched them, and they saw the exact same one of these strings, they can then determine that you're using the same password for both accounts. Does that make sense? You want it to be, every time you run it, different. So this is an even more secure layer that it's adding on. Even if I use the same password, which you should not, do not, then it will come up as a different string in different databases. Cool? Are there any questions as to using the exact same password, which you should not do, is a different string, a different hashified string with bcrypt in different databases? Who understands that sentence? Awesome, interesting, cool. So what I want to be able to do is I want to just like store this cool password, right? And it comes out as this, cool pass. Huh. And as promised, is this a string? No. It looked like a string, but it is not. Right? So if I were to do cool pass, and I were to say, is that double equal to PA Rivers?
False. True. Oh, I know.
Bizarre, huh? Bizarre. Tell me why.
Because you saved it to that. Cool password is an instance of here.
And what thing?
Sorry, that was the bcrypt password.
Let me ask you this then.
Me personally.
Yes. True or false?
Oh, that's a good question.
Probably false. Seems like true.
This is the Mike Chang experience. Ready? Who thinks true? Who thinks false? And who thinks I'm trying to trick you?
Oh, yeah, definitely.
Absolutely, yeah, false. This should irritate all of you.
It does.
This should irritate you. Let me explain. Has anyone heard of monkey patching?
Yes.
Cool, what is that? That's right, forcing the code to do my will. Absolutely. But it's specifically called monkey patching because you're overwriting a commonly used method or a method that's already built in, and you're overwriting it with your own. So for example, I can easily just jump into something like class array, and then I can say, oh, that was weird. You shouldn't like try to evaluate that. Huh. That sounds weird. It's just no, it should totally do it. But either way, bizarre. All right, let's just open IRB. Fresh old IRB, class array. Cool. And inside, what's a popular array method? Length, right? Length is fine. So I can do a new method called length, and I can just simply return. What would you like it to return?
Long.
Very long. Very good. I can end the length method. I can end the class. And then on any old array, let's say 1, 2, 3, and I were to say, what is the length?
Very long.
It is very long. Cool. And so this is called monkey patching. Very dangerous and often frowned upon. However, there are important times when this would be useful. So, for example, let's say I were to do something like this, and I were to do, do something like this, and I were to do something like this. What is this again? What type of object? What type of object? And what is this? String. Let's take a look at this code one more time. Where is this? It inherits from string, and then it does something very interesting. It overwrites the double equals. So it does something different from what you assume and what it looks like. And what it does is it runs super on the bcrypt engine, passing in the hash secret with the secret and the salt, and I'll explain that here in a second. This right here, while it is in this public gem source code, it is not available to you. So I showed you where it's not, yeah? Does that count as like a weird check on the box?
Yeah.
Cool.
Does that mean the two MIT guys would know everyone's password?
Interesting.
Yeah, it has to be.
I want to say no. Here's why. The secret is going to be part of that long hash, and then the salt is going to be part of that hash as well. The salt is a random piece of data based on the type of computer you're using, the version of your OS, and the time of day. And literally one or two other things that I just don't know about. And I don't really care to know. As I'm studying more cybersecurity, I probably should know. Yeah.
So if you're using Super for the bcrypt engine, and that's in like a server somewhere that we can't reach, but we're using the gem, which is in the public domain, you can still call methods even though not both of them are public or.
There's a dependency on this that is not public.
Oh, okay.
Yeah. So, at salt, what does this look like to you? What does this at mean? Right? And what do we have here? Salt. You can read it, so we can check it. What is the, I don't need this anymore. Go! Cool pass, which is the secret password object. What is the salt? You check it out. It's these first characters. Huh? What? It feels what?
Feels wrong.
What about it feels wrong? Okay.
Learning the secrets.
Learning the secrets of the password.
It gets even more wild. So this is a fun lecture, right? There's just not a lot of code. So you have the salt here along with the secret. And so you'd have to know when this person created the account, on what computer, on what version, on what OS, and that's kind of how it runs on Mac. It runs differently on Linux and on PC. So you really had to like have been there, you know? And so the idea here is that it needs to be one way. So the best analogy I can, wait, are there any like vegetarians in here? Like vegetarian? Yes. Okay, great. So let's just say you had like a vegetable grinder, right? And in this vegetable grinder, you put in this like celery, and then you put in broccoli, right? Thank you, very good. And you just grinded these vegetables up, and you're left with this green mush on the bottom. Cool? Can you tell by purely looking at it what parts and components are in there? No, you can't. You see this sort of green mush. But through modern science and technology, is there a way to extract the DNA to see, hey, is there any celery in here? Is there any broccoli? And is there any Brussels sprouts? Can you determine that? Yes. So you can check to see what the origins are, but is there any way to take, again, this green mush, put it back in the vegetable grinder, reverse the crank, and get a clean stalk of broccoli?
Yeah.
Not yet. And that is good enough for today as of April 16, 2019. Very good. This lecture is still valid. There's no way to reverse engineer that process. And that's why this is secure. Does that make sense? I will tell you, however, that if you have one of the common passwords, like let's just say I did this. Cool pass, right? Is your common password 1, 2, 3, 4? No. Is it 1, 2, 3, 4, 5? Is it password? Oh, God. I can literally attack this. If I have the object, I can check it against hundreds of thousands of common strings until it runs true. That is what is known as a rainbow table. I'm literally going to take anything I've stolen and check against, hey, is it this password? No. Is it this password? No. Is it this password? All I have to do is build up a database large enough to encompass essentially every string. Now, is it physically possible to crack a password? 100% yes. With enough time and enough resources, I can crack it, right? Like at this point, if you guys want to stay here super late for the next 8 years, I'm going to keep guessing. It's just going to take forever. So do not use a common password. And that's why they ask you, who's like had an account where like, hey, it needs to be 8 characters long with one number, with one string, with half your social security number, and at least your grandmother's maiden name. And you're like, all right, great, sure, whatever. That's why the password's so hard to crack, because once you start adding special characters in there, it's so much harder to guess. Even changing password to something like this, you seen this common bad boy over here? $1 not both, and then instead of O, you have, that's right, capital O. Very good. That changes it significantly, and it becomes harder to guess. I'm not saying this should be your this should not be your password. That's actually what I'm saying. But when, change it. But when there's like a hacker trying to guess it, do you see why there's these security measures in place now? Cool, like I've like pulled back the curtain for you. I know, the wizard's just smoke and mirrors, right? So, cool. Sorry about that. Learning. But now everything you learn is kind of true. So, does everyone understand kind of how this is working, why it's beneficial, the extra security layers that are put in place? Why would we use something like this to store into the database? Okay, great. I want to show you one more thing. If I were to take this object, right, like a bcrypt object, Because the tricky part is this works right here. This works. But what do I need inside cool pass? What was cool pass? Let's check it out. Ready? History. Cool pass. What, you like that? You don't like that? Cool pass, I actually needed the text of the password. The problem is, what do I actually have? Oops. What do I actually have? This is what I have in the database. So I need to use this along with the plain text password the user gives me, and I need to compare them. This is how it's done. You take your bcrypt, you take your bcrypt password, and you take it in. I did. Thank you. That was very embarrassing. And create and new are different. Create will actually attempt to create a new one, where here, new is going to be utilized to make an instance of bcrypt that can take in the string. Oops. Oh, God.
No.
I know. I'm sorry. This will only take a second. Cool. Now, think about the login form. Do you remember the login form real quick? Let's take a look at localhost 3000. Oh, it's busy. It's still in this. Imagine this said login, right? It'll look the same. Come on now, you know that. Username and password, right? And then somebody typed in PA rivers. How does that come across as params? In a hash. So params at a key of password. So here, in theory, I could do, yeah? But here, I mean, I don't know if we actually have params. Here I'm going to check, hey, is this equal to PA rivers? This is the user input, and I have this in my database. But if I were to do PA river 00, negative Batman, that is incorrect. Try again. So new and create are different. New is simply going to be utilized to check. Create is going to be utilized to actually make the hash, the stringified hash. Yeah. Yes?
How come you wouldn't use like a find file instead?
Oh, because I didn't write the password class.
Okay.
Yeah. That is a good question. But yeah, it's like different. So like it initializes, right? So new is being overwritten and it does something different.
Okay.
Right? Cool. So let's actually like get this to work now, right? Wow. There's a lot of concepts there. How are we feeling about bcrypt as it relates to being able to hashify something? One-way transformation, extra security layer by not creating the same hash, what a salt is. All right, let's move. Continue. Cool. It says unknown attribute password for user, which makes sense, right? Because remember, I actually attempted, unknown attribute password for user. I attempted to save the password. So what I really need to do is this password create. So remember, this password is going to intercept the params. So what it's going to need to do is do this bad boy. And I'm actually going to create a new one using the plain text password that I got. PTPW, plain text password. And I'm actually going to do this. I'm going to take in the hashified string and assign it to the password digest attribute of my model. That way, when I actually save it to the database, it gets saved as a hashified string inside the password digest attribute. Thank you. That's the reaction I'm looking for. Only one person. Sorry. Stop the madness. No. Questions on literally this line right here, 12. Why we did self.password digest and assigned it to this new instance of the bcrypt password. Cool. Someone tell me why we did that.
So we can use it later.
Sure.
So we can authenticate.
Okay, there's a lot of that. So we can store a hashified string in the database so that we're not storing plain text. I'm literally creating the hashified string and then I'm storing it into the database. Yeah, let's take a look, see and what that looks like. If I were to go to users new, and then I were to go ya boy, and my password is PA Jack Rivers, and I were to actually go into the bybug, I check my params. Do I want to do that? Let me do user.create with my user params. See what happens. Huh. Username your boy, password digest, hashified string.
Wow.
That is safe. That's powerful. Who feels comfortable, by show of hands, understanding how that happened with the custom adder reader and writer we wrote in the model? Yeah, cool, good. All right, great. That is complete. Now we need to be able to actually like authenticate somebody. Because great, it's stored in there, but we haven't actually authenticated. And as I promised, this lecture is all about authentication. So we don't actually need this, and I promise you that this lecture will be about 20 lines, but it's really going to be one line of code, and you'll see later. It's disgusting. We want to authenticate someone. What do you want to name this method? Wow. Wow, I just had a brain fart. I had a huge brain fart there.
The suspense.
Yeah, great. So as we've learned, authenticate can take in any arguments, right? Let's just say a plain text password. Think about this right here, ready? I'm gonna log in. When the user logs in and hits the login button, it's gonna hit what route? Probably like a post to /login or something. It's gonna hit some sort of controller action. Maybe the user controller at some sort of method called authenticate, or like, am I the real person? I don't know. And in there, I'm gonna call this method. I will pass in user.authenticate, passing in the param set a key of password. So remember, this is going to be inside the login, right? I'm going to invoke this method on a user object, and I'm going to pass in the plain text password. This will make way more sense when we get to part 2, right? But the idea here is I need some sort of method to actually check somebody. So how can I do that? I have password digest. And what is password digest right now? That disgusting string, right? Let's take a look at history. Cool. Is there a way that with just the plain text password and the string from my database, can I check to see if that is in fact correct?
Yeah.
Cool. Bloop. Like that? Okay, bcrypt password new. I can simply go bloop and replace it right here. And that, is this still gonna be PA Rivers? The plain text password I passed on. So if this is true, then return what? Like return the user. Right? So now I need to do what? Like if this is true. Yeah, I could do a bunch of things, right? But essentially I want to be able to like return like true. Like, hey, that person is who they say they are, right? The password that's in my database matches the password that they gave me. Cool? I would then probably use, like if authenticate is true, then I'll probably do something like user.findBy, the username, right? I'll probably return like user.findBy, and I'll take in the params. I'm sorry, find by the username with the params of like username. Because remember, I'm in the login point now, right? I just need to like think through abstractly. But for now, it's kind of not important. Let's just say true. Else, nah dog, wrong, PW. Right? Like this was wrong. So the idea here is that what I really want to do is return true, or the user object, or false if this doesn't work out. Are there any questions as to what this method does and why we wrote this line of code?
Why don't we call self dot anywhere in there?
We can. It is implied, but this is more explicit, yeah. I mean, you don't really need this though, right? Like, I mean, do you really need this? Right? You can even cut that down.
So based on convention and monkey patching, you will always want to put the decrypt password dynamic on the left side of the comparator.
You have to, yes. This has to be on the left side because it's going to call the double equals on the bcrypt object. You don't want the double equals on the string object, right? That's very good. So the other thing it does, was that a question or just stretch? Yes.
Don't we have to find the user and password digest for the user first, and then we check for the password? By the username?
No, you're taking in the params. This will make more sense in the login. I just need you to understand like what this authenticate is doing. Cool?
So this isn't necessarily about your authenticate, but it's just something I'm curious about. When you are doing like the login with the username and password, it's best to give them their own specific table and not any other data in it because it's confusing.
I'm sorry, you lost me. What? Say it one more time.
So when you're storing this, you need to store it into a table, correct? And you just, on that table, all you want is the username and login, right?
All I want is a username and login. It depends on your model, but if you want like an email address instead of a username, like a first name instead of a username and password.
Okay, so you can put other things on the table without
Yes.
getting okay.
If you're using bcrypt, you must use password digest. It is like the one thing that's required because of like how this is working here. That being said, it will also do one more thing. It will validates, right, your password digest, and it has to be there. I think this is an object. Cool. You like being upset?
Always. I think you're about to make me happy.
Okay, that's the whole lecture, this one line of code. Powerful. Plus, plus. Yeah.
So nothing else needs to be in the controller.
Say again?
Nothing else needs to be in the controller. It's just this.
No. So Rails, however, the one thing I do want to point out, I forgot to say, is in your gem file, you have bcrypt. By default, it is commented. You simply uncomment, and then you run.
Fun.
Money.
I know that one.
Nailed it. And then you put has secure password in the user, and this is what it will build for you.
Great.
Cool? Are there any questions on authentication? These 4 things it will build, right? The add a reader, the add a writer, overwriting, so you can save the hashified string into your database, this authenticate method, which we will use in part 2 of the lecture, and then the validation. Yeah.
That line doesn't need any extra like, options or parameters in it?
No. This is a method that bcrypt will invoke that gives you this. Yeah.
That's cheap. Also, do is create the password digest.
Yes. Somewhere in your user model, right? Or your like painter model, or your like plumber model if you're building like a, I don't know, arts and crafts construction website. I don't know. If whatever you want, that has a password to it that can log in needs this line of code and bcrypt. Cool? All right, great. I look forward to seeing you this afternoon. Go work on a project.